Hi, I'm Jadi and this is LPIC. Welcome back again. The wait is 4. Important session. Create, monitor and kill processes. Create is a little bit strange. You're running programs. Maybe it means do configurations while creating. Maybe. Candidates should be able to perform basic process management, run jobs in foreground and background, signal programs, monitor activities, select and sort processes for display, send signals to processes. Okay, you have lots of terms, but it's easy. I will go through this section in 3 different parts. First is creating and managing. The second part is monitoring. Kill will go here. It's part of the managing. And then we will have a look at multiplexer in the third section. But let's now I have my Debian. Let's show you a couple of programs I'm going to use. These are cool. Not sure if they're installed by default on your distro, but you can try to install them. One is called X-Eyes. X-Eyes. X means this graphical environment. These are the eyes looking into my mouse cursor. I ran it. I have to break it. It's like a normal window. So when I run it here, it's running here. When I come here, I do not have control over the bash. Practically, I ran it in my shell. Now this X-eye is in controlling the input and output. If it writes something on the screen, you will see it here. If I type something, it will go to the X-eyes. If X-eyes ask for an input, it doesn't ask. So I don't have my shell. X-eyes is running and I'm here. If I want to stop it, I will do a classical control C. We'll keep the control down and push the C and we'll break it. Control C broke the X-eyes and gave me back my terminal. Once more. I can run also X clock. Normally X clock doesn't show the seconds. So if I want to show it, I will break it. It says update interval is 1 second. So I will need the third hand. Is it called hand? I believe so. So it's running. I do not have the control of the shell. If I enter something here, type something here, it will go to this program. But this program is not asking for any input. So no usage. And if this writes anything on the output, it will go here. I'm using a couple of graphical GUI programs to show it better. If I want to stop this, I will go with Control C and now it's gone. Next step. X-eyes. It's running. With Control C, I can break it. There is one more command. Control Z. I kept the control and pushed Z. Control C was breaking the program. Control Z stopped this command. This is the output of the jobs. You have a command which is called jobs, which will show you the jobs running or stopped, jobs present in this shell, in this session. Jobs shows that I have only one command running. This is X-eyes. This is it. But this is stopped because I pushed Control Z. So if I move my mouse, this funky little eyes won't follow it because it's stopped. If I want to make it run, I can say foreground. %1. This % says I want to give you the number of the job I'm asking you to start, which is this one. But you can see that we have a plus sign here. So if I omit this, this one will be used because this is the default one. So I had a program running. With Control Z, I stopped it. So it's not in running state anymore. And on jobs, I can see that I have one process running kind of, but it's stopped. I can say bring it to foreground. And it's in foreground. If I move my mouse, now you can see that it's working, but it kept the focus focus of the shell. Now my shell I cannot issue new commands anymore because now eyes is in foreground. I can do a Control Z. Now eyes is stopped. If I move the mouse, it doesn't follow. It's stopped. I can run another program. Say xclock update interval is 1. So I have this running. I can do a Control Z here. Now that one is also stopped. The hand is not running anymore. If I do a jobs, you can see that I have two jobs in this terminal. One is X eyes and it's stopped. The other one is xclock update 1 and it is stopped. You can start any of them in the foreground. So I can say foreground %, which one you want? Let's go with the clock. Clock is number 2. So I have to say %2 or omit it completely because it has a plus here and this is the one which is being used if I don't mention any number. So I say foreground. And my clock is back, set on the new time, and it's working cool. But the problem is still I'm only having one of them running. If I do a Control Z, stopped again. So jobs will show me that I have two processes in this shell, X eyes, X clock, and both are stopped. I want them to be running, but I want my shell back. Up to now I was doing foreground %1, which will continue running this, but this will steal the shell, so I cannot issue any commands. I cannot work with my shell. Control Z, jobs. I can say instead of foreground, I can say run it in background. Run in background %1. So jobs. Now my X eyes is running in the background. This ampersand will tell it's running in the background. X clock is stopped. So if I move my cursor, you can see that these little eyes are watching it and it's running in the background. I have my shell because I'm in the foreground. I can do whatever I want. I can check jobs once more. I can say background %2 or omit it completely because you can see the plus sign. So this is the default. If I don't say anything, this is the one which goes to the background. Look at the second's hand and it's running. Jobs. I have two jobs running in the background. This tells me that this is running in the background. So what we learned. Jobs will show the jobs in this specific session. When you issue a command and press enter, it's running in the foreground. So output of it, std_out, will go to this shell, and whatever you type in the shell will work as std_in, so you don't have your shell anymore. Control Z will stop it, so the process is not running. You will get back your shell. Jobs can show that it is stopped. You can bring it to the foreground with foreground command. Foreground %, one number, for example, this one, or omit it, and the one with the plus will be used. This way, you will bring that process to the foreground. Again, output will go to the std_out and to your shell, and whatever you do in your shell will go as the input to this program you brought to the foreground. And if you do the same but with background, the command will continue to run. It will go into the running state, but in the background. So the output will still go to the shell, but whatever you type in the shell is used for the shell itself, and you can issue new commands. Let me show this with the ping for you. Why this is good? Because when you are connecting to the server, this lets you to run different commands and take the control back of your shell, so you can do different things. On a GUI system, I can, for example, ping
this, and now I can't do anything anymore because I'm running a command. This can be a calculation which takes 1 hour. So on a GUI system, if I want to work with that, I have to run another shell, and in this shell I can do whatever I want, issue another command. On a remote system, you have to keep this open and just waiting and watching it. So as a solution, you can say, I ran it in the foreground and I don't have any possibility to run anything anymore. So I will do a Control Z. Now it is stopped jobs. As you can see, I have different commands. XI is running in the background. Clock is running in the background. Ping is stopped. So okay, continue the ping. Background %3, or as you know why, you can omit this. Now it's running, but it has some output. The output comes to your shell, but you have the control of the shell too. So if I do an ls here, ls will work. If I do a very slow ls like L, the output is coming here. I say S, output is coming here. Push enter, another output is being added. So I have different things running and showing their output on my shell. This is one of the usages of the redirecting. For example, say you have a huge calculation and you want to run it on your server. You would say, Python, my calculation, send the output to blah blah, send the error, as you know how to do it, to blah blah, or no, show me the errors and just send the output here. And you will have the control if you send it to the background. If I want to take control, Control L deletes the page. So it's deleted. Control L, jobs, these are the jobs I have. I want to stop this one, so I can bring this one to foreground. I can say foreground %3, enter. Now it is in the foreground. I can say Control Z, now it's stopped, or Control C to completely break it. Jobs, now it's stopped. I can say foreground %3 or nothing. It is in foreground. Control C will break it. This is how you send different programs running stop to the foreground or to the background. What we had was we ran something, Control Z, ouch. We ran something, Control Z stopped it. Then we were able to bring it to foreground or background. There is another easier way to run something directly in the background. I can say XIs. I can tell it a geometry. Geometry, I believe. 100 in 100. This is the size. This is the position. So I'm saying 100 in 100, showing in the 0 position. This is running here. When I wanted to send it to the background, I would do a Control Z and then BG or BG %3. Now it's running in the background and working. If I wanted to do this directly, I could do 1000 and 0 and this and would tell the bash to run this process directly in the background and give me back the control of my shell, which is so cool because now it's running here. The other one is also running. The other one we had here is also running, but they are running directly in the background. If I do a jobs, I can see that I have 4 running in the background. One is X clock. The other ones are X eyes. So we saw that if you are running a command, you can say this command ampersand, and this will run directly in the background, and you will have the control. So I can say ping, ouch, ping 4224 in the background. Sorry, I have some network issues. This is a remote screen. Now I'm running this ping in the background. I have my control. I can say jobs. It says these are running. I can say foreground. Will foreground the last command or foreground %5, as you can see here. Now it is in the foreground. Control C will break it. Do some of these stuff with yourself, and you will learn a lot. But what's the issue? You have a server. Okay, I connected to my server, for example, with SSH. Now I'm doing this stuff, my processes are running. And I decide, okay, let's go back to home, let's disconnect, let's log out, and everything is gone. Because everything was running inside this shell. And when you close this shell, the Linux will tell all the processes that you should disconnect yourself, you should terminate yourself because your parent is dead. This is what happens in most cases in computer world. In the real world, people continue after their parents are killed or go and take back the revenge. Anyway, this was the X-eyes. Another X-eyes is running here. Another X-eyes. The other one was only 1 pixel. Another one is running here. These are all running directly in the background, so it's easier to what? I was thinking to show you another command that is called nohup. Normally you solve it. If I'm in a shell and if I'm running a command there in the foreground, in the background, whatever, and if I close this shell, which is closing it from here, on a GUI machine, graphical user interface, or disconnecting from a server. Anyway, if I kill this shell, whatever in it will die. But we have one command to help us here, and that's nohup. If you say nohup, don't hop, this command, and then close this shell, this command will continue to run. For example, if I say nohup xcalc, which is xcalculator, sorry, where is my calculator? It's here. When I say nohup a command, what happens is I say nohup a command or whatever argument after it. Nohup says ignoring input, no input, and appending output to this file. It creates a file and append whatever output this command has to that file. And this is a nohup command. So even if I close this shell, all the X-eyes will be killed because they were running normally, but my xcalc will continue to run because I ran it using the nohup. It says, okay, something is running, should I close myself? Yes. So this is very super useful. You connect to a server, you run a command, and if I do a jobs here, nothing will appear. Why? Because this calculator is from another shell. It doesn't has anything to do with this specific new shell I opened, but it's being run, and if it has any output, it will go to a nohup txt file. The std_out will be redirected here. Why this is useful? You have a huge calculation, you have a server, you have a whatever, and you connect to your server, you run your program as nohup blah blah, and then you disconnect. And this program continues to run on that server. Even on a server, it's a good idea if you are creating a huge archive, for example with tar, as a backup, you say tar create file my back, what to backup, everything. So it creates the my back.tar in your root directory and will append whatever in your system to it. This may take 1 hour. So you have to keep connected. If you disconnect, everything is gone. So you just easily add a nohup and run this. Then disconnect, connect later, check the nohup txt and see what's the output of your command. Or even when you are issuing the command, you can say nohup tar create file blah blah, and add an ampersand here. So you will get back your shell and the backup is working for itself. It's a very, very cool feature and highly used. I forgot to tell you that on the jobs command, for example, if I have this x eyes, another x eyes, a little bit further. This is the size and this is the position. If I do a jobs here, it shows me 2 with their jobs ID. If I do with -L, it will also show the process ID. Whatever is running on a Linux machine has a process ID or PID. So this is the process ID of this task. And nohup, I showed you, this is very, very common to do this and say nohup, run my script, send the output here, send the error to the same file. Oh, sorry, it's not nohup. I think it's nohup out, not nohup txt. Anyway, and run it in the background. Let me check that. You can run whatever with nohup. For example, if I do a nohup ping 4224 with an and, so it will go to the background directly. It will give me back the control of the machine and also shows me the process ID which started because I was running in background. And yes, it is nohup out, sorry, not nohup txt. And if I do a tail-f nohup out, it will show me line by line all the, come on computer, every data which goes into it, it will show it. I think 2 different nohups pings are running. That's why it is like this. Later I will show you how we can kill this. But even if I kill this window, that ping will continue to run because I ran it with nohup. So if I again do a tail-f nohup.out, you can see that it's still data is going there because that process is being run and sending its output to nohup out. Then we have this kill command. Despite its strange and frightening name, the kill command doesn't kill things. It's technically, it sends a signal to a process ID. So if I run something here and say, for example, x eyes, run it in background, says okay, oh sorry, says okay, I'm running x eyes in the background and my process ID is 2480. My x eyes are here. They're very fun. We used to have one x eyes running here older times, 20 years ago in Linux world, and that would keep us happy. Maybe that's why people are not that happy anymore. Run your x eyes. It's good practice. Run your x eyes using nohup and the background and then close the window. Anyway, I ran an x eyes. This is the process ID. I can send different signals with dash some signal to 2480. If I don't say any signal, if I omit this part, the system will send signal 15, which is known as signal term. I will ask this program to terminate itself politely. There is one more, which is -9. I think I have them here. Yes. 15 is term. Politely will ask a process to terminate itself. -9 is kill. It's aggressively. Even if you are doing something, even if you are not understanding my commands, whatever, just kill the process. And -1 is a hop signal. Hop signal informs the process that its controlling terminal is terminated. So the signal, the process will terminate itself after getting 1. Unless you were running it with nohup. Now you can know why the name is nohup. I say nohup, blah blah. So if you got the hop signal, which means that your parent terminal died or stopped, don't kill yourself. You are a nohup. Don't give any attention to the hop signal. Let's try this. So I have this xis. This is the running process number, PID. I can say kill. Where was my xis? It's here. Since I can say kill 2480. So practically I'm saying send signal 15, which is term, to this one. Ask it to terminate itself. It just did it. Sometimes people hang, processes hang, sometimes people hang, but processes hang, and you cannot send normal kill. In that case, you say kill -9. You're telling it to die. So it will die even it has something to do, its file is open or whatever. And sometimes you're more aggressive and you say sudo kill -9 a process ID. And this will send the kill with the root access because you're adding sudo. We'll see this later with in more detail, but in general, you know, if you add a sudo, you are doing it as a root. So sudo kill -9, a process ID for sure will kill this process ID. But the problem is sometimes we don't have the process IDs. For example, I don't know the process ID of this calculator. What should I do? And when you kill something, when something is finished, the jobs will show you that this is terminated. Now it won't show anything anymore, but because we had it and we killed it, you will see a terminated message here. As I told you, sometimes we don't have the process IDs. There is a way to find them. We'll speak them in the next half an hour, but in the next part of this module. But we have two commands. One is kill all. When you say kill all, you can give it a name. For example, say Python. Practically, you are saying send signal 15, because this is the default, to whatever process which is called Python. Or you can say -9 and explicitly say I'm too aggressive, or check other signals. The other one, the kill all, will send this to all the ones with this specific name. pkill is the killing using regexes. You say pkill, for example, -9, send the -9 signal, which is a harsh killing, to whatever has eyes in it. So if you have X eyes, it will be dead. If you have eyes music, that will be dead, and everything else. That's kind of dangerous. So if I have a calculator here, if I don't know the process ID and I just want to kill it, I can say pkill whatever has calc in it, and it's dead. It's kind of dangerous because you may kill something which you have not planned the killing of. Anyway, let me do a quick review. What we saw was we ran a command, then with Control Z we stopped it. It was in stopped status. So I could do a foreground on it. It would take back the shell and the input and output and was running. Or I could do a background, which would not take over the shell. So now output will go to the same shell, but my input will be used as the next command in the shell. So you cannot give it an input unless you do a redirection, which you know. If you wanted to run directly in the background, you would add this ampersand, or you could do nohup, a command, ampersand or not. This would continue even after the shell running this is closed. We had jobs, showed us the jobs. We had kill, sends signals, kill, nohup, and then we will go to monitoring. We will talk about the things that we can monitor processes. Although you saw kill all, pgrep, and
pkill. You have not seen pgrep yet. And pkill. So we were able to kill things based on their name. Pkill x would kill whatever has x in its name, not only the x itself. Kill all x will kill only the process name x, as much as you have. Let's go to the next session. That's more cool. We will do some monitoring.